Welcome all student friends. Here with myself, Assistant Professor Pausai Narsai. We are discussing a master degree program, second year, organic chemistry. The subject is CHO 351. Under a new revised syllabus, it is a core course, CCTP 8. This is structure determination of organic compound by spectroscopic method. We look for a recapitulations. Now, everyone is somewhat known about the chemistry. And as you look for a chemistry, the most of the times you will be think that about a small particles, that is atom. And if you look for the atom, then somewhat bigger, you look for molecule. You everyone know about that atom molecules. But if you feel so, number of different compounds you are using in day-to-day life is having a specific structure, and which compound is used for which purpose, that you have to look, and according to that structure the effect of the compound will be observed for that activity. And the structure determination is the most important thing will be discussed under a chemistry subject, and the name of that subject in short we call as spectroscopy. These had wide applications, but you think what is a structure? What is meant by structure? What is called as a structure? Everyone know about every molecule is having a specific size, having specific shape, bond length, bond angle, and a orientations of a group in a 3 dimensions. So that the structure of the molecule for every compound is a different. And to determine a structure, we specifically used two methods in a laboratory. And the first method is your chemical method. Under a chemical method, we can going to perform a analysis. We call as a quantitative analysis. That is, how much quantity of the substance is present or will be required. According to that, a partial information about a structure is observed. Now, a day, we are also going to perform a qualitative analysis, in that a functional group estimation. That is, which type of functional group is having a compound. According to that, we get idea about the functionality of that compound. With addition with the functional group, we also go for a elements, that is in hydrocarbon. Everyone know there is a presence of carbon and hydrogen. But in addition with that, there are other elements are also present, and we detect all these elements under a element detection criteria. Under this criteria, if you detect the element, you again get somewhat more information. It is create a way to approach a perfect structure. Then we are also try for a different preparation methods by doing derivative preparations or oxidation, reduction type of reactions, and all such changes when you are performing. Then we again have somewhat informations about a structure, but we are unable to get a perfect structure. Sometimes to get idea about the presence of double bond or triple bond, that is unsaturation in a structure, we also do the reduction or degradation type of reactions. And moreover, chemical reactions or chemical method we can choose to determine a structure. In addition with that, we take a support of a physical methods, because the physical methods represent a different for a different compound. Which are these one? Basically, physical constants are there, which includes boiling point, melting points. Then the refractive indices, dipole moment, mass, etc. These physical properties also tends to idea to determine an structure. Furthermore, these methods are elaborated to a technique, that is X-ray crystallography, in mid of the 19th century, and the newly methods after that is a spectroscopic method. We get a more information, not over more information, but we predict up to the correct structure by using that spectroscopic methods. Look at some advantages and a very few disadvantages. The first advantage of the spectroscopic technique is you require a very small amount of sample. In a microgram of the sample quantity, you can get easily analysis. And second one, whatever the sample you have used, it will get recovered. That means there is no loss of the sample. You get analysis and you also get a recovery of the sample. Third thing, the time required for the analysis is very small. Quick analysis is there, so there is no requirement to wait for a long time to get a results. And whatever the results you got, this gives perfect idea about the structure information. These are the few advantages and very few disadvantages if you look, is that the instrument cost is high one. So it is not easily bear with each and every institute. And another one, you require and trained person. These are only two disadvantages we can say, but this is a quick method, so we can get easily analysis, and due to that we can perform a number of samples by the use of 10 persons if you purchase a single instrument, so that these disadvantages we can take advantages and go for what is mean by actual spectroscopy. Friends, everyone aware about the light, and the light it travels in a straight line, and the light will be travels in a straight line. There are there are some other important phenomena are there by which the light will be get interfered or diffracted or diffractions. And by considering all these phenomena, this light is actually travels in the form of wave. Actual the visible lights is in the form of energy. These things are explained by a complementary theories, that is corpuscular theory and a wave theory. According to a wave theory, light travels in the form of wave, and we call it as a radiant energy is going to emit by a fluctuation of electric charge and magnetic field. Due to this electric charge and magnetic field, the fluctuation will be got. It's considered as a wave, and the different electromagnetic radiations, ultraviolet light, infrared, X-ray, and radio wave. These are the similar form of the lights. Then the question is that what is the spectroscopy? It is a simply we called we take an object, and on that object the radiation will be strike. We call this radiation as electromagnetic radiation, and the object is nothing but a matter. And then there is some interactions present between this matter and the radiations, so that if you do the study of that interactions of the matter and or that the past radiations, it's called as a spectroscopy. In a simple way, we study the light from an object. What I say? We study the light from an object. And to record this light, which is going to spread out to give a spectra, this instrument is called spectrometer. Then what is a spectra? Spectra is just a range of electromagnetic energy separated by a wavelength. Or in a simple way that we call as it is a graph which is represents electromagnetic energy and a wavelength. Now this spectroscopy deals with a two type of things. One is called as emission and second one is a absorption. Actually these are the type of spectra. Emission, everyone know. When we strike a radiation over a matter or object, the atom will be get excited and it is going to produce a energy. This energy is emitted and after emission of that energy, the spectra will be formed called emission spectra. The simply we say if you take a hot object and from that the vapors will be come out, like the same phenomena is there. This emission spectrum will be observed. It's simply a discharge of a vapor at low pressure. If you observe, or a high pressure, you get a evolution of vapors from hot surface. The similar is that the vapor which will be removed out, that is like a radiation will be get removed out. And this discharge is happen here by means of electric, and this electric discharge will be passed through the vapors of that substance, and the energy of the substance is get absorbed, and electrons present in the ground state are going to promote to a metastable state. Second thing, again this electron from metastable state jump to lower energy state, and that time some energy of a definite frequency is released as a radiations, and this radiation is analyzed with the help of spectroscopy. This is a simple phenomena of emission spectra. Okay, what is that? Just we have to take a strongly heated substance, or simply we say a electric discharge we are going to pass over a substance. The energy will be absorbed by that substance. Then electron in ground state promoted to metastable state. From metastable it jump to the lower energy state, and when it jump to the lower energy, a definite frequency is removed out, and this definite frequency is known as a emission. It is recorded in the form of spectra called as emission spectra. Now the absorption is a when you pass and radiations, but now here we are going to pass the radiation of certain energy and for some time. Then we look how much amount of energy of or that certain wavelength are get absorbed by that substance, so that its characteristics like a particular functional groups is present in that compound will be find out. And here we got a dark pattern of the lines of the corresponding wavelength. This absorption spectra, after absorption, transmit the light, and this transmitted light is actually absorbed, analyzed by a spectrometer, and will be compared with a incident light. That means incident light frequency and transmitted light frequency will be comparatively analyzed, and the absorption spectra energy will be get by means of the heat up with the sample, or it is going to look how much will be going to re-emit it. This is a simple diagram of emission versus absorption. Look, this simple phenomena. In the emission, the energy will be released in the form of like vapors from a hot substances, and this will be recorded in the form of spectrum. Dark spectrum is known as emission spectrum. And in absorption, a certain wavelength of radiations will be strike on a cold substance. It will absorb that energy and transmit this again further, and the comparative study of absorbed and transmitted will be recorded in the form of absorption spectrum. That means how much will be applied and how much will be get transmitted. This is the phenomena of emission and absorption. So herewith we define spectroscopy. That is, it is a method of analysis based on interaction, absorption, or production of light by matter. Now in this we can easily say that interactions of the electron will be included, ions, acoustics with that of the matter. And we say that we require a light. Which light? Light is a electromagnetic radiations. This is a electromagnetic radiation spectrum. Now these radiations having different wavelengths. Actually the longer wavelength are less energetic, and if you say a cosmic rays which is having the maximum energy, then radio waves are the very least one, and according to this phenomena we say microwave have longer wavelength and are mostly used in the telephone transmissions. Whatever we are going to talk over the mobiles, these are the your radio waves, or we say microwave. The two different view of the light will be given. A wave models here with there we have the crust and trough will be observed, and these wave models in the crust and trough will be given by the sinusoidal wave, which is traveling in the space with an oscillating electric field and perfectly perpendicular to a magnetic field. Now, the terms some we are discussing here, the first is about the amplitude. Now, in these waves, the maximum displacement of the wave is given by amplitude. Okay, here we say the height of wave, electric vector, maximum displacement, and wavelength is the distance between two peak. We take the crust or we take a trough and determine the distance in the form of nanometer, centimeter or meter is called as a wavelength. And wave number is just a reciprocal of the wavelength, hence it is a centimeter inverse we can show. This is again a diagram which represent wave blue lines, while these red lines will be about a electric field. The vibrations will be done in upward or in a to and fro motions will be there. In the wave model, another one important is the frequency, a number of cycles per second. Okay, this is look this. In a 1 second, how many number of cycles will be observed? And this number of cycles or oscillations per second is called as a your frequency. The second thing is about the velocity of the propagation. That is rate in which it is going to travel through a space which is dependent upon the media, and in the which medium it is going to travel, it has a less or more number of oscillations. And you observe a maximum velocity according to the speed of the light in a vacuum, and in air somewhat lesser, nearly 0.03% than in the other media. If you look in a less dense medium, it will be show maximum, while in a more denser, it is having the somewhat less frequency. This is the simply we observe when you transmit from less dense medium to the more dense medium. This is a difference. In air medium, we observe that lambda max is a 500 nanometers. In a glass, it become 330 nanometer. That is from less denser, more will be the wavelength, and in a denser medium, somewhat less will be the wavelength will be observed. Another one is the particle model. In the particle model, the energy will be in the form of bundles, or we call the discrete bundles, and this is known as the photons. And these particles will be sometimes scattered or counted, quantized. According to that, we can find out the energy. If you apply h mu amount of the energy, then there is a energy will be required to proton to transfer from lower energy to the higher energy levels. We can calculate the difference, and as the energy of the wave particles, we can take E is equal to h mu, and mu frequency is explained by c upon lambda, or we can consider is equal to hc, where h is the Planck's constant, mu is a frequency, lambda is a wavelength, and a mu bar is a wave number is there. Okay, this is gone upward, and you must have to know some note. energy is proportional to the frequency and the wave number. As this is energy will be increased, wave number is increases, and it is inversely proportional to the wavelength. As wavelength is increased, energy decrease, or vice versa. In the electromagnetic radiations, if you look in the nature, there are wide range of types of the electromagnetic radiation. Over a small fractions of 350 to 780 nanometer is in the visible lights. This is your visible light will be observed, and if you go this spectroscopic radiation, you have the gamma, X-ray, both hard and soft, UV light, then visible, infrared, microwave, radio, and the wavelengths. If you look in a different uh, type of the compounds, atomic nucleus 10 raised to minus 14, atoms 10 raised to minus 10, virus, bacteria, dust, pinheads. These are given in a centimeter values. Your fingernails, our human, skyscrapers, Mount Everest. This is given for the frequency and the wavelength range will be there. Will be clearly observed that the more wavelength will be observed in atomic nucleus, with wavelength for the human is 1, and Mount Everest there is a 10 raised to 4th more wavelength will be observed, and then less energy. Okay, that is we learn a matter, and over that matter the energy will be strike, that is in the form of radiations, and in the form of radiation as the energy will be strike, we will be get a different type of spectrum. This is the Crompton effect. Look at the photoelectric effect. It will be strike and the electron will be going to ejected in a pair productions. The radiation will be strike, two pairs will be formed, and in a photo disintegration radiation will be strike and multiple uh, sub small particles will be formed or ions will be formed. And the coherent scattering, if you look, the molecules will be going to show such type of radiations. These are the different way to learn about a matter or the electromagnetic radiations. Now we must have to know about some concept like a period, a time required for one cycle to pass a fixed point in a space. A frequency is a number of cycles which pass to a specific point within a second. The amplitude is the maximum displacement of the or of the wave. Wavelength is just a distance between maxima and minima or crest and trough, that is identical adjacent points. Wave numbers will be expressed in centimeter, and radiant power, which is the amount of energy reaching to the area, unit is a watt, and intensity is the radiant power per unit solid angles. Okay, thank you once again for your cooperations. For more videos, you can subscribe and click on the bell icon. You get the notification as we put a new video. Thank you. Welcome.